Okay, so in the last learning targets, we've talked about linear functions, how to graph linear functions in learning target 3, and how to write linear functions for data, whether it's tables, situations, graphs, in learning target 4. In learning target 5, we're going to talk about how to determine if a table, graph, or situation is a linear function, which means can we model it with a linear function? Because if it's not a linear function, we can't model it with one. So we can't write an equation for it. So let's look at first at how to decide if a table is a linear function. And so the question for a table that you have to ask yourself is, does it have a constant change throughout? So if we look at this first one, it's going up 2, up 2, up 2, up 1, up 1, up 1. The whole way it's going to be 2 over 1. So it does have a constant change, 2, and so it is linear. So I will write linear right there. Now let's look at this one. From 5 to 10, it's going up 5. From 10 to 20, it's going up 10. From 20 to 25, it's going up 5. Over here, so right now oops, not 55. So right now, it kind of looks like it's not linear, but if the same change is also occurring over here, it will be okay. So let's see. If we have -3 to -6, that's going down 3. -6 to -9 is down 3. And -9 to -12 is down 3. So we really have two slopes going on. We have 5 over -3, and we have 10 over -3. So we have 5 over -3, and we have 10 over -3. Because it's not the same slope the whole way down, this is not linear. Now let's look at this one. From 0 to 2, it goes up 2. From 2 to 6, it goes up 4. From 6 to 8, it goes up 2. On first glance, I might think this is not linear, but let's look really quickly here to see if maybe it actually is. Because if this same change is also happening over here, then it will be okay. So from 4 to 8, it goes up 4. From 8 to 16, it goes up 8. And from 16 to 20, it goes up 4. So again, we have two different slopes happening. We have 2 over 4. And we also have 4 over 8. Those are equal to each other. They're actually the same. 2 over 4 equals 4 over 8. If you were to reduce 4 over 8, you would get 2 over 4. And then that could even reduce further to 1/2. So this is linear. Even though the slope looks different throughout it, they're actually equivalent. For a graph, you're just going to ask yourself, is it a straight line the whole way? That is linear. This is not linear. Even if you have two straight lines put together, not linear. A linear is one straight line the whole way. Yes? No? No. Yes, linear? Not. Even though this is two straight lines, it's not a linear function because it's not one straight line the whole way. For a situation, you have to really think about the situation and then ask yourself, does the situation increase or decrease at a constant rate the whole way? Sometimes it's good to make a table that models the situation to decide. So if you think about this situation, let's say, a girl saves $30 each week from her new job. The independent variable would be how many weeks she saves. The dependent variable would be the amount of money that she has. So if she saves for 0 weeks, she wouldn't have any money. If she saves for 1 week, she would have $30. 2 weeks, she would have 60. 3 weeks, she would have 90 because she saves $30 for each week at her new job. So if we look to see if this has a constant rate, goes up 30, goes up 30, goes up 30, goes up 1, goes up 1, goes up 1, 30 over 1, the whole way. So yes, it is linear. Now let's look at this one. It says a baby doubles in weight every 6 months. So for this, we kind of have to have a starting place. So at 0 months, we're just going to, because I'm just trying to determine if this is a linear situation or not, I'm just going to think in my head, what if? Because there's not any exact information here about what the baby's original weight was. So I'm just going to make something up and then just make sure that whatever I make up is doubling every 6 months. So we have 0, and I'm just going to say that this baby is 8 pounds to start with. After 6 months, then the baby would be 16 pounds because his weight doubled. After 12 months, his weight would be 32 pounds because his weight is doubling. After 18 months, his weight would be 64 pounds. Now, first of all, this table is quickly becoming not accurate. That would be realistic, that would be realistic, probably not realistic, probably not realistic. But besides that, if we just take that out of it, let's just decide if this represents a linear situation or not. This is going up 8, it's going up 16, and then from 32 to 64, it's going up 32. This is going up 6, 6, 6. So if you have 8 over 6, 16 over 6, and 32 over 6, we know that this is not linear. Because 8 over 6 does not equal 16 over 6, which does not equal 32 over 6. Those are 3 very different slopes. So this is not a linear function. And that is how you determine if a table, graph, or situation is linear or not. You just look to see if it is the same rate of change the whole way through.